what do we have? So we've got x equals cot t plus 2. No, not cot t, cos t. Cos t plus 2 and y equals 4, not 4 over 4 sec t. So here I'm trying to find a relationship between cos and sec. So I'm going to just go through that now. I could write this as 4 over cos t. Are you happy with that? Does that make sense? And so x minus 2 equals cos t. And once I've got that, then I can replace cos t with 4 over x minus 2. And that's it. And there's my answer done. I've got a Cartesian equation there. Are you happy with that? I'm going to go through C as well. So it's a lot easier than you think it was, wasn't it? It wasn't really, there wasn't any identity we had to use there. All right, okay. If I think about the next one, part C, x equals cos t. So for these, the key, like I was saying yesterday, is to find the trig relationship between what we have. So in this case, I need to find a relationship between cos t and cos 2t. That's what I'm trying to do. Can you please tell me in the chat what the relationship is? What is the relationship linking cos t with cos 2t? If you have your trig sheet handy, this makes life a lot easier. So if I think about it, we know 3 versions of cos 2t, but there's only one with just cos in it. So cos 2t is the same as 2 cos squared t minus 1. That's right. Okay, so now, well, how am I going to get cos t by itself? If I do y over 2, I get cos 2t. So I can replace the left-hand side of this identity with y over 2. And then I've got 2 cos squared, 2 is a constant, cos squared t. If x equals cos t, cos squared t is going to be equal to x squared. So we get 2x squared minus 1. And finally, all I need to do to make y the subject is multiply all of the right-hand side by 2. And I might simplify that to 4x squared minus 2. Does that make sense? Are you happy with that? Okay, perfect. Right, so the next thing that I want to look at, something to do with domain and range as well. Right, number 7, please, here. I want you to have a go at this, and again, like yesterday, just talk me through what you're trying in the chat so that I can point you in the right direction. Okay, so before you try something, let me know what you are trying so that I can go through it with you. So I could convert the cot squared 2t in terms of sine and cos. I think that's going to make it more difficult, or it's going to increase my workload. What I would do is try converting sine squared 2t into something else. Okay, so for the cot, I won't change the cot, but I might change the sine squared. And you're going to realize why once you try it. X over 3 sounds okay. What is the underlying identity that we might use in this particular set of parametric equations? That's the first question I ask myself. I look at these two equations, I think, okay, here are the trig terms. What underlying identities, maybe more than one, that I can use to help me get to the Cartesian equation? Maybe you can start off with doing that and typing that in the chat, please. What underlying trig equation, trig identity do we need to use? This is where hopefully you've got some sort of trig formula sheet handy near you, so you can just look at that and pick out the one. Sorry. Well, let me know if you get stuck on this as well. I said leave the cot as it is. I've got a cot squared. I can do x over 3 equals cot squared 2t. And then I can do y over 3 equals sine squared 2t. I now need to find a relationship between cot squared and sine squared. And actually, there's only one relationship really that I know about cot squared. Can you please tell me what trig identity do we know about cot squared t? So you should be thinking 1 plus cot squared 2t equals cosec squared 2t. Yeah, that's good. In this case, we replace x with t. That's all we've done. Okay, so that's very good. Now, cot squared is fine. So I can say 1 plus cot squared I can replace with x over 3. How am I going to get cosec squared from this highlighted thing here? How am I going to get cosec squared from y over 3 equals sine squared 2t? Yeah, essentially, you've got to think about if sine squared 2t equals y over 3, if I flip this the other way around, I get cosec squared 2t. Because cosec squared is the inverse, or sorry, the reciprocal of sine squared. So now I can replace cosec squared 2t with 3 over y. Does that make sense? Are you happy with that? And then from there, you have to go about making y the subject, because in the question, we have been asked to put it in the form y equals f of x. Y equals f of x implies make y the subject. Okay, so you've got that. Now you can take over from this equation and let me know what you get for y in the chat as soon as you're done. What we can see is if I need to make y the subject, I'll do multiply the y across 1 plus x over 3 equals 3, y equals 3 over 1 plus x over 3. Now you might be asked to simplify this. So how are we going to do that? We're going to write this as 3 plus x all over 3. Which is the same as saying 3 divided by 3 plus x over 3. So change that to times and flip this upside down, and so we get 9 over 3 plus x. Which really is how we should leave it. We shouldn't have a fraction over a fraction. Okay, we don't really want to do that. Okay, now I want you to have a go at the domain and let me know what you get for that, please. We said domain refers to the x values. So what are we going to do? I'm going to wait for you to tell me in the chat. How am I going to go about determining what the domain is? That's good, yeah. we think about it, for x values, we need to draw x against t. Right, let's have a look. So now what we need to do is sketch x equals 3 cot squared 2t between the limits of 0 and pi over 4. I don't want to do that in one go. I want to do it step by step until I build up to the full transformation. So what base graph should I start off with to draw this, please? What base graph should I start off with to draw this? Your underlying graph that I'm going to start off with in this case is going to be cot t. Now if I think about cot t, looks like that up to pi here. This is pi over 2 and goes, this is x, this is t, but that's not the graph we want to draw. We only want it up to pi over 4. Now if we think about it, there are two transformations taking place. There is this and there is this transformation. Now, what is the impact of that 2t? So this was cot t. I'm now going to sketch cot 2t. What impact will cot 2t have? Please tell me in the chat on the graph. How am I going to draw cot 2t? X values divided by 2, opposite of what we would expect, or times by a half. Okay, so now instead of taking pi, if this takes pi over 2, and this point here is pi over 4. Are you happy with that? Does that make sense? So cot 2t, this is us saying f of 2x. And then finally, I am going to do x equals 3 cot, well actually, there's one more, cot squared 2t. What is the impact of squaring going to become? What is the impact of squaring going to become? Any negative values are now going to become positive, because when you square any negative values, such as these y values here, if we square that, they are going to become positive, and this bit here is pi over 2, and this is pi over 4. And then finally, we're going to do x equals 3 cot squared 2t. Well, this is multiplying our y values by 3, which we can't show on here because it goes up to positive infinity anyway. And we only want to see x values between 0 and pi over 4. Sorry, t values between 0 and pi over 4, because t is restricted to that. So now I can disregard this bit. So looking at this, if t is greater than 0 but less than or equal to pi over 4, can you please tell me what is the domain? What are the allowable x values? looking at this graph. You should now all be able to pick it up from here. Is pi over 4, is that allowed in the value for t? Yes, it is. So the lowest value on this graph is 0, and it goes up to infinity at the top because this goes up forever over there. The key thing here to understand is because pi over 4 is allowed, we get an x value of 0. And that is allowed. So we should say x is greater than or equal to 0. Okay, this is the key tricky bit that you need to understand, which many students miss out on sometimes, the equal to bit. Okay, any questions there? X equals 2 cos t. And y equals sine t minus pi over 6. Right, so when I look at this, because both the angles aren't the same, this being the angle and this being the angle, I can't use sine squared t plus cos squared t. I can only use that if both the angles are the same. So my thought process is to take the right hand side here and do the sine A minus B rule. So I'm going to do that now. Y equals sine t cos pi over 6 minus cos t sine pi over 6. Are we happy with that? Does that make sense? Because that's the only one thing I can really do here. So then if I think about this, I know what cos of 30 degrees is. So I can write this as root 3 over 2 sine t. And I can write this as a half cos t. I'll be happy with that. Now is the bit where we can start sort of substituting things in. So you can say x over 2 equals cos t. I know that for sure, so then I could say y equals root 3 over 2 sine t minus a half times by x over 2. I'm doing it step by step. So the only thing I know at the moment is that cos t and cos t, because they're the same, I can replace them with x over 2. Now, by that logic, cos squared t is going to become x over 2 squared, but cos squared t is also 1 minus sine squared t. And so sine squared t equals 1 minus x over 2 squared. And sine t, therefore, is going to be the square root of 1 minus x over 2 squared. Does that make sense? Is everyone happy with that? Is everyone following what I'm doing there? Any questions? So now from this, we can do y equals root 3 over 2. Sine t, I'm going to replace with square root of 1 minus x over 2 squared minus x over 4. Are we happy with that? So there's only one bit under the square root, two terms, and then you've also got minus x over 4 outside. Now it's just a case of simplifying until you get to what we have got over there. I want you to have a go at that and let me know how you get on. Yeah, can you explain that? How did you find sign differently? It should still be the same thing. Let's have a look. It's going to be very similar. So cos t equals x over 2. Here's t, this must be x, this must be 2. So this is square root of 4 minus x squared. That's right, isn't it? That's what you got. Is that what you did there? Can you let me know? And so sine t should have been equal to square root of 4 minus x squared over 2. Okay, so now you figured out where you made a mistake. Okay, that's cool. But that's fine. Okay, you can do that and you get the same answer. Right, I am going to simplify this so that you can see how to get there. Root 3 over 2. This square root is going to become 1 minus x squared over 4. And I've also got minus x over 4 outside. Root 3 over 2 is fine in here. If I put this over the same denominator, I get square root of 4 minus x squared over 4 minus x over 4. So, continuing on with that. If I now write this as root 3 times by root 4 minus x squared over 2 times by root 4 minus x over 4. If I multiply third multiplied by third, I multiply the third, so I get square root of 12 minus 3x squared. 2 times by root 4 is 2, so 2 times by 2 is 4 minus x over 4. And then finally we see that 1 over 4 is common in both terms, so we can take 1 over 4 out. We've got square root of 12 minus 3x squared minus x. And so we've done that there. Okay, let me know if you managed to show that yourself. If there was any problems, can you figure out where your mistake happened? Why weren't you able to do this? And also, let's say this was an A-star question. As long as you sort of got up to here, you've got majority of the marks. Maybe you've got 3. You're going to get 1 more mark for domain and probably 2 more marks for manipulation of this thing. Okay, so you sometimes if you're just not making progress, just think to yourself, as long as you've got majority of the marks, move on, and then if you've got time, come back to that later. Now, domain, how can we show that x lies between 2 and minus 2, please? Please explain to me, everybody in the chat. How have we determined that x lies between minus 2 and 2? This is important and an area where students often lose marks. How are we going to show that the domain is minus 2 to 2? Right, what you should be saying to me for this is you sketch x against t. So x equals 2 cos t, and we need to sketch that between 0 and pi. Well, I'm going to start off by sketching just cos t, 1 minus 1, and I've sketched it between 0 and 2 pi. But here is 0 and pi, so it's still 1 and minus 1. So this is cos t. But if I want to sketch 2 cos t, the transformation is that I need to multiply my y values by 2. So actually, yeah, this becomes 2, this becomes minus 2, but I'm going to rub out the bit of the curve which I only want to go up to pi. So I only want to go up to here. I ignore everything else. Here is pi, because t can only lie between 0 and pi. And so my lowest value is down here, my highest value is in line with this, 2 and minus 2. But t was not allowed to be 0, and t was not allowed to be pi, so we can't include 2 and minus 2. And therefore, x is greater than minus 2 and less than 2. Does that make sense? Are you happy with that? But if we do it sort of a long-winded way around, we know tan squared is linked to sec squared. Okay, so we know that tan squared and sec squared are linked, and I can get to sec using sine squared and cos squared. So it's sort of two identities that we need to be using here. 1 plus tan squared t, I guess, equals sec squared t, and the other one would have been 1 plus, not 1 plus, sine squared t plus cos squared t equals 1. So let's see how this sort of pans out. So this one was one that required double sort of manipulation. So if I think about it, x minus 5 equals tan squared t, and that's fine. I can then say y over 5 equals sine t. Now I am trying to use this one primarily, so I need to get sec squared To get sec squared, I need cos squared. And to get cos squared, we are using sine squared. So hopefully you can see the links there. And what we're doing here is that we are now going to square this and get sine squared t equals y over 5 all squared. But we also know that sine squared is the same as 1 minus cos squared t. So we've got y over 5 squared equals 1 minus cos squared t. And from this, we can make cos squared t the subject. We can say this is y over 5, 1 minus y over 5 squared. Right, okay. If I just simplify this, so 1 minus y squared over 25, and if I now put it over one denominator, just so that I can do the reciprocal easily, and so I get 25 minus y squared all over 25 is cos squared t. Can you please tell me in the chat how I'm going to get sec squared t from this? How am I going to get sec squared t if I know what cos squared t is? Do 1 over. We can do 1 over or just flip it. That will be quicker. We don't want to keep them 1 over because we might lose ourselves in there. So we get 25 over 25 minus y squared. Does that make sense? Can you please let me know in the chat if everyone has followed everything that I've done there? Any questions? Have I lost anyone there? Right, okay, so now that we've got sec squared t, and we said we are going to use 1 plus tan squared t equals sec squared t. This is what we have so far. 1 is a constant, that's fine. We worked out tan squared earlier was x minus 5. And we've got sec squared, which we've just worked out over here as 25 over 25 minus y squared. So now we are pretty much there. We've got the Cartesian equation, but again, this question requires us to put it in the format y squared equals f of x. So we need to make y squared the subject now. So how am I going to do that? I'll multiply this denominator across to the top left hand side. So 25 minus y squared times y, 1 plus x minus 5 is the same as saying x minus 4. So this is being multiplied by x minus 4 equals 25. Let me just rub this bit out here. And so we get 25 minus y squared equals 25 over x minus 4. And if I want to make y squared the subject, I'll move this fraction to the left-hand side and move y squared over to the right-hand side. So we get 25 minus 25 over x minus 4 equals y squared, which you can, of course, put it over one denominator. So that's one answer maybe. Or the other answer, if I treat this as two fractions and I cross multiply, we get 25 times by x minus 4 minus 25 all over x minus 4. And if I simplify this, we get 25x minus 100 minus 25 all over x minus 4 minus 125 over x minus 4. So there is, oh well, they've not done any of that, so that's fine. It's the same thing. I've just simplified it a lot more than I needed to, I guess. But you can see at each stage what we're doing. Right, okay, so last question now. I still want you to have a go at the domain question. So this now is asking for domain and range. I want you to let me know how you are going to work out the domain and range through the chat. Tell me what you're trying to work that out, and I can then give you feedback on that. So for part B, for domain, we said multiple times sketch x against t. And so firstly, my base graph is x equals tan t. And so I'm only looking at t values of between 0 and pi over 2. So I'm going to draw a sketch only between 0 and pi over 2. Here's tan t between 0 and pi over 2. But then I'm going to do my next transformation, x equals tan squared t. But if I square it, between 0 and pi over 2, nothing really is going to happen. It's just going to become steeper. And I get up to that stage. Now the next thing that I want to do is say x equals tan squared t plus 5. So you can see how I'm building this up. If I add 5 to it, will it start at the origin though, is the question. It's now going to start at just under 5. And this is pi over 2. And this is 5, sorry, just over. Okay, so now if I look at my domain, my lowest height is down here, and it goes up to positive infinity up there. And so if t is greater than 0, it's not allowed to be 0. It's going to be just over 5, so my domain is x is greater than 5. Does that make sense? Are you happy with that? Please let me know that in the chat. Can you see how I did it? I want a response from everyone there. Right, okay. I want you to now have a go at the range. Yeah, so this is what I'm saying. Yeah, just self-assess and understand where the difficulties lie for you, so that you know. And let me know in the chat as well, so that in a week or so's time, I'm going to test you again on this, so that I can know whether you are doing this correctly or not. Right, I want the range for this as well, please. Yeah, curve sketching is the skill really. That is the problematic thing. You understand how to work out range and domain, I'm guessing. And the problem is being able to sketch the curves. So maybe we'll do a lesson on curve sketching and transformations of graphs. Okay, I still want you to have a go at the range. Let me know what your y values are, please. Right, so how are we going to do the range? Well, we're going to sketch y against t. And we've got y equals 5 sine t. So my base graph is sine t. So if I think about sine t between 0 and 90 degrees, it's only going to look like this. There's 1 and there's pi over 2. And so my next thing I'm going to do, so this was sine t. And if I think about 5 sine t, multiply y values by 5, this is still pi over 2. My lowest height is 0, and my highest height is 5. But t is not allowed to be 0 or pi over 2, so we're going to say y is less than 5 and greater than 0, which would have been impossible to work out from the parametric curve. Sorry, the Cartesian curve. Okay, so try figuring out your y values from that. It's impossible. Okay, are we happy with that? Any questions? Right, okay, guys, thank you very much. We'll call that a lesson. I do want you to try some more questions on this because you're going to know that you're not finding this a bit tricky. Maybe have a go at number 5 because that's a bit different, and number 8 as well. All right, guys, thank you very much. See you same time tomorrow. You're welcome.